Hi, everyone. I'm Edward Fagin. I'm the VP of Engineering at MediaMath. So I run the data services team at MediaMath, and what I want to tell you about today is how and why we decided to move from a batch-oriented, I think of it as monolithic, but after a day of hearing about microservices, we'll call it a monolithic batch-oriented log shipping pipeline, and move to more of a dynamic stream processing one. I want to talk a little bit first about MediaMath in general, who we are, just to provide some context. So how many of you in the room are familiar with how online advertising works today? Okay, maybe a third of the room. I'll go into it briefly then. I think it's helpful context. So imagine like a news site, right, a publisher page, and across the top of the page you might have a banner, a block, a rectangle on the top, down the side a couple of blocks. Each of those is effectively blank real estate, right? When the page first loads, it's an empty container. And for each of those blocks, the news site, publisher, whatever, works with an auction house, an exchange, to actually conduct a real-time auction. There's about 150 billion of these every day, right? So this is a tremendous number of operations. Not to mention, they all have to complete on that page before the page even renders. So this is like 30 milliseconds tops right now for all of those auctions to complete in parallel. So this is a big data problem, really, at its core. Where MediaMath comes in is, in order to really participate in those auctions at scale, you need a pretty big global dynamic intelligent platform that can bid at that volume, at that 150 billion requests per day, 2.3 million requests per second is what we're seeing right now. So it's a big platform. And our advertisers come to us, advertisers, agencies, media buyers, they come to us with their ads, so the images they want to serve, the videos, whatever it might be, and their outcomes. So in this case, what users they're looking for, what time of day they want to show these ads, and so on. So they come to us with all of this, and we go and bid on their behalf with our platform, with these exchanges. And so that's really what MediaMath does in a nutshell. This talk could very easily be about online advertising for an hour. I'm not going to do that. This is really about data and data streaming. So just if you're about to run out, oh God, it's about advertising. It's not. So hopefully that sits well. So what MediaMath needed to do was build a system that could handle all of this data at scale. And so our team's job is to really wrangle and distribute that data internally to all of the different consumers that might need it. So in order to do that, we recently built what we call internally MediaMath's Firehose. This is Firehose in a nutshell. So I'll jump into a lot of the blocks on here in depth as we go through the slides, but for now, what you're seeing here is really a stream processing flow where Firehose ultimately is collecting different events, so things that are happening online that we're collecting. It's streaming all of those to different consumers of that data. So one example of a consumer might be our data management layer that's trying to figure out what our users are doing right this second and targeting them. So in the example of a user bought something, and we want to maybe serve them an ad as a result of that, or in a lot of cases stop serving them an ad because they just bought the thing. We're able to do that instantly, in near real time, where before, and I'll go into this in the next section, it wasn't really always that way. So this is an architecture talk. It's sort of half architecture, half business use case, and really how we got to this point. And so one thing, and this is sort of the accidental architect track, right? So one thing that we discovered going through this, as many of you I'm sure have, is that we didn't really have any guiding principles going into this. What we had was a rather monolithic system that was very batch-oriented, and we needed to fix it. That's sort of where we were. So we, over time, developed these guiding principles that I think they came out of the build of Firehose, and I wanted to share them with you initially because I think of these as really the driving principles behind all future development of this thing that we've built now. The first is that stream processing should feed batch processing. It's kind of a weird concept to get used to, but the idea is that data that hits your system, right? If you're collecting user clicks, things they're doing online, that information's flying in very quickly, right? Generally, you have a web tier that's collecting this data, very high velocity data. What you really want to avoid is taking that data and just grinding it to a halt the second it hits your platform, the second it hits your system. So if you're familiar with like a web server, that does log rotate and writes to disk. The second you get a message, it sits around for about an hour, then you ship it off to a warehouse. What we wanted to do was be able to support those batch use cases without sacrificing the momentum that was inherent to the data. I think that's very important to remember. The second is that messages should move off of producers quickly. This is ultimately a reliability concern. If you have producers of data, that really, and I'll go into what I mean by producers a bit more, but if you have data sitting on the collector tier, right? The data's sitting around, maybe you haven't fully moved that rotated log file off the disk yet, and the server goes down. All the data that hasn't been shipped to your warehouse yet is lost. It's gone to time, you're never getting that back. So we've had these problems enough that we realized one of the goals of this should be to get messages off the producers as quickly as possible in the spirit of the first bullet, which is maintain the momentum of the data. So for those of you that are familiar with systems like this and have had a big web tier collector layer go down and take hours worth of data with it, as I have, you never want to see that ever happen again. The last is also related, which is that schema changes should flow downstream with your data. And I can't stress this one enough because it's come back to bite us so many times, not just in my current role, but in other companies I've worked for, where imagine the scenario of a producer of data. A producer here is really the collector of data, a web app that is logging what it's seeing online. It's logging this information, say it's a CSV file. Many of you have probably had experience with a web server that logs a CSV file of all the things it's received. That CSV file, or Apache access log, or what have you, generally the log rotate schemes, how often you roll that log, or what fields go into that log, are driven very decisively by the downstream consumer. In a lot of cases, the data warehouse. So maybe the warehouse has 7 columns. They expect the third column to be the timestamp, and that timestamp is an ISO timestamp, and it has to always be that way. So your producer tends to start logging things, right? It starts to generating data based on these demands of the consumer. The way I visualize that is that that's schema flowing against the grain of the data, right? If the consumer at the far end of the stream is declaring that this is the schema that I expect, if you have a tightly coupled system where data is shipped through it, that schema tends to flow up with the data. What you want, this is what we realize, is that you want the data to flow downstream with the data as it gets collected all the way through, and tell the consumers what the schema is. Don't ask them. So those are the 3 really core principles that emerged as part of this build-out. So in this talk, I wanted to start with just some of the challenges that we had at MediaMath and really the impetus for Firehose. Then go into some basics of messaging, some of the really core architectural ideas that we started to learn. And again, like any architectural idea, there's not a lot of books on the subject. A lot of this is like, we're sort of figuring it out as we go. These are concepts that we're reading about in blogs. The technology's coming really fast. So these are our interpretations and really my interpretations of different architectural concepts that drove Firehose. And then finally, what we built and why we did it. So we started off a couple years ago with a fairly batch monolith. So I'll briefly detail the types of data we're collecting because I feel that that's useful. Bidder data. So this is really our auction layer. So I mentioned earlier that there's 2.3 million requests per second hitting our system. These are auction opportunities, right? These are exchanges saying, hey, MediaMath and others, do you want to bid on this ad or not, right? And in some cases, we bid, and in some of those cases, we win. And when we win, right, that is us showing an ad to an end user on our client's behalf. We need to know that that happened every single time. That's how we get billed. That's something our clients want to know, need to know. So those are what I consider wins. The next data source is site events. So these are things that our users are doing on our clients' sites. Things like saw a product page, or clicked on something, or put something in their cart, or bought something. Right? These are also critical transactional data points. The last one is third-party segments. So MediaMath has a lot of a really dynamic ecosystem of data partners. And data's coming in through offline channels, online channels. We have server-side HTTP. There's a lot of ways in which we ingest data on behalf of these partners. So I wanted to include that here, as I think a lot of you probably have ingest pipelines like that too. So that's the different types of data. This is a pure batch architecture. So the middle section, highlight the phrase log file. What we were doing was rolling these log files. Messages would hit our collection layer, our web tier, and we would record these messages as they came in, write them to a log file, and then every 15 minutes, hour, depends on the system, it's on the order of minutes, we would rotate that log, which means we would compress it, we would move it out of the actively being written to file directory and put it into the ready to be shipped file directory. I'm seeing some nods. This is something that many of you have dealt with. So once it gets into that place, you want to move it to a central repository where it can then be analyzed. So we had an rsync process and lots of bash scripting, and it was tons of fun, trust me, to take these log files and ship them over to the warehouse. On the other end, the warehouse was a giant Netezza appliance, right? So I actually like it, but that's what we had. Sort of unscalable in that you needed to buy more of these appliances, very expensive investments in our data center. So that's where we were a couple of years ago. Now, where we wanted to go was very different than where we were. And we realized this pretty early on, that we had a pretty tremendous hurdle to overcome. In the first case, tight coupling. Again, if you're taking these log files, compressing them on your producer nodes, and shipping them all the way to your consumers intact, that's a very tightly coupled system, right? What that means is that nothing changes about that file. That file is basically immutable as it flows through the pipeline. It's just important to remember that that's a tightly coupled system. You can't transform the file. If those of you are familiar with the phrase ETL, it's really not happening until it gets to the consumer. ETL being extract, transform, load. Somebody can call me on that one later. In addition, these are slow pipelines. If you're logging to a file every, let's say, hour for the sake of simplicity, after that hour, your log file is essentially locked and then shipped. It's at least an hour minimum before consumers of that data can look at it, can use it, which if you're doing something like a nightly report like we were, that's fine, totally reasonable, scale's great. But if you want to do something a little more dynamic, a little more real time, not really possible. I did put in parentheses, but reliable, because when you're logging to a file, locking that file, shipping that file as the contract is really easy to track compared to, say, an individual message. So that's something that I want to, it's a pretty reliable pipeline. What we wanted was to dramatically speed up that pipeline without losing the reliability that was inherent to it. As I mentioned, things like our impression data, our wins, and our purchase information, we can't lose that. If we just lost the purchase, that's money we're losing, right? This is financial transactional data. So reliability was just as important to us as it was before. In addition, we have beefy producers. What I mean by this is, back to the lossiness problem, if your producer goes down, if your web tier that's collecting data goes down, any of those nodes, the data that hasn't been shipped off yet is gone. It is lost to time. What we wanted was, instead of beefy, expensive, in-data center producers, we wanted this concept of highly available producers, right? If any one of them went down, that's all right. Not a big deal. We'll spin up another one. All the messages that were on it have been shipped off of it by this point. No harm, no foul. That's where we wanted to get to. We also wanted to get away from the big appliance. Instead of one big appliance, we wanted multiple consumers. We wanted them to be horizontally scalable. We wanted Hadoop. We wanted Cassandra. We wanted to do some really cool stuff in the space. But with the very tightly coupled architecture we had, this expectation that there was just that one consumer with just that one expectation of schema was very tightly baked into everything that we were doing at the time. So that's where we were and where we wanted to go. That was kind of a fun problem. It was a full redesign. We knew that there are other talks I know at even this conference about when to do a V2 versus when to maybe not rebuild your entire system and maybe incrementally do stuff. In this case, we had a pretty early detection that we were going to have to rewrite the whole thing. There's really no way to go around that, which has engineering-wide impact, right? You are working with every team that needs this data, is producing this data, to make sure that they're able to move with you in this rebuild. Very disruptive. At the same time, we couldn't be disruptive to the business, right? You can't take offline your data collection system until you've built a new one that doesn't work. So you have to build a new one in parallel, and this is the whole change the oil on the plane while it's crashing and burning. There's a lot of metaphors for this one. In addition, this is fun. Rebuilding, we're talking about using cloud now and moving out of the data center. We started throwing around phrases like microservices and fun stuff that maybe some of you have heard of at this point in this conference. But I think of this as like the modern architect's dream project, right? Taking a monolith or a batch system and just modernizing it, making it work for current and future use cases. That's something that I think everyone in this room can get behind. I don't know about all of you. I think most of you are in this position at least. After a day or two here, I just want to go back and do a ton of things at work. I want to go fix things and tinker, and it's really exciting. So this was one of those projects. I'm very excited, but before I jump into Firehose in any more depth, I felt it important to go into messaging basics, as, again, viewed by me, yours truly. These are my interpretations of messaging basics. There are tons of blog posts, books, et cetera, on the topic. But this is us trying to make sense of the ecosystem before we went and built. So to start with some common terms that we ran into, input. Right? Input would be what people are doing online, a user action. The example I really like is a click. Right? A user clicked on an ad. That's an interesting user action or input. The producer layer, and I've said producer a couple times, this is a web server. It can be whatever kind of web server you want, some basic play framework thing, or whatever you want to do. Collects data, logs it to disk, or logs it to somewhere. This is a producer in this sense. And I'll stop for a second. I think producer and consumer, before I confuse anybody, this is like the client server of messaging where it really depends on where you're standing, right? One person's input is another person's output. So just to be clear, when I'm talking about input through output, I'm talking about it from the perspective of our messaging system and how we were viewing the world, where input was really things our users were doing online, and output were things our customers wanted. But I just want to put that in the business context. The message is the fundamental concept here, right? What is a message? A message is ultimately this core atomic immutable thing that you want to move through your system as the lifeblood of your data pipeline. Right? It is fundamentally different than input. Right? Input might be an observation, a thing you're listening for, a click, et cetera. What you're logging is the user ID that did that, the timestamp they did it, right? What they clicked on, all the information, the user agent. So these are fundamentals that go into your message. Determining how you structure that message becomes very important too. Is it a JSON blob? Is it whatever? So I just wanted to distinguish the difference between input and message. Then there's consumers of data, which in our case was this big warehouse. An output, which might be a report. So the example I like is we're collecting clicks, as per the input example. If we're collecting all of these clicks, maybe a client wants to know what happened. So who is clicking where? I want to know all of my clicks yesterday, broken down by geographic location. Right? So in a classic data warehouse mode, one thing we might do is say, okay, well, we're logging IP addresses. And, well, maybe the first 3 octets of them. And we can do enough to figure out the rough geographic location of the user who clicked. And we can join all of this in the warehouse, like the big geo IP map, and all the click data, and join them with some sort of SQL join, and spit out a table or a report or Excel file, what have you. We realized, though, that that wasn't super scalable, especially back to the core thing that we wanted to do of add more consumers. If you had your data warehouse doing all of this join, the second you had another consumer that also wanted this geodata, well, you didn't really want to do it in that one consumer. You want to do it further upstream so that everybody can benefit from this simple operation. So we'll put something in the middle that can do transforms. It can do IP to geo lookups. It can take user agent and figure out the browser and operating system, and filters. I think the best example of filter is, say your input is what users are doing online, and your consumer just wants clicks, right? People who clicked on ads. They don't want purchases. They don't want all of the images that person looked at. I mean, it's really, let's say 1% of your total data stream is what this consumer wants. In this batch mode, where all the data flows through at once, the consumer has to sift through everything, right? And search for just the little needle in the big haystack that they're trying to find. So we put a filter layer that said, you know what? Forget the noise, we're going to send the signal right to the consumer, because that's ultimately what they want. Once we had that layer in the middle, we found, well, now we can have more than one producer and more than one consumer, and have this layer in the middle really be the routing exchange layer that was super valuable to us. So that's basics of messaging from our perspective. And for those of you who have more advanced knowledge of messaging systems, this talk is only 45, 50 minutes. I'm not going to go into pub sub versus brokers and all of that. Happy to stick around afterward and talk to people about that, because I'm always very excited about that. Just don't have tons of time today. Just wanted to note that. So basics of messaging aside, that tells really the types of boxes in a block diagram if you're building a messaging system, but how the data moves through is just as important as what it's moving through. I categorize these as really 2 ends of a spectrum. where the first end is batch, right? Pure batch, where you are stopping data, right? Big stop sign saying, I'm going to wait until I'm happy filling my bucket brigade, and I'm moving this bucket of data over to the next person who wants it. And then on the other end of the spectrum is stream, which is really message by message. So let's take a look at those briefly. Batch. So I define it as large groups of sequential messages. Depending on the literature, et cetera, they might not be sequential, they might be non-sequential messages. But I think of it as just a log that you're writing in time order, so the order in which you observed the input. These tend to be high latency, again, because you're batching, you're waiting for the bucket to fill. And typically, not always, be very clear, not always, just typically, these include log rotation and shipping. Sometimes it doesn't, but usually it does. Always on loading, right? What always on loading means is that you're sort of capturing this data, and the consumers of data need to know all of it, right? You're putting it into a warehouse or into an archive or somewhere where you really need everything, all of the data for as far back as your servers can handle, as far back as your SAN can store it or whatever. In addition, as I mentioned before, these tend to see schema defined by the consumers, the fixed CSV file, et cetera. But that's not a bad thing. Again, it's an end of a spectrum. Why might you use it? It's great for big data processing workflows. Really, like you're trying to look back through long data windows. You're trying to look at what is going on in your system for the last month, right? Batch is great for that. If you don't really care what happened, say, in the last midnight last night GMT to now, batch is awesome. Why wouldn't you use that? You can look back, it's static. If it's immutable event data, it never changes, so that's great. In addition, if you have one consumer of data that just has this long data window use case, this is awesome. And this is, again, why we had the system we had. It was built out of a desire to really generate value for our customers early on in our company's history. The last bit is that the file is the contract. And this is back to being really easy to track messages through the system. If your file is the thing you're tracking, you get kind of two really nice advantages. Maybe there's more, but two that I can think of. The first is it's just this easy thing to track. You look at the file name, you can tell if your file name is awesome. You can tell what server it came from, maybe what day and time it was generated. And from just the file name, you can figure out basically everything that's in that file. So say you're searching for, I want to know clicks that happen between X and Y date in our Eastern Europe data center, right, at this time window. You can just look for all the file names that you know about. And that's an index where you can zoom right in and grab what you need. That's really powerful. In addition, having a file of similar messages, again, if these are like very similar CSV files or Apache logs, it's extremely compressible, right? The data is all very similar across your log file. So your compression ratios can get pretty good. On the other end of the spectrum is stream. So unlike batch, where it's this bucket brigade of filling your bucket and shipping it off, stream is really about messages flowing individually, where the message is really the contract or the thing that you're tracking. These tend to be lower latency, again, because as soon as you receive a message, your bucket of one is filled and you can ship it off. This typically includes applications logging directly to a message queue. You'll see this in a lot of streaming systems. Sometimes that's not always the case. Like you might have a system where your application is logging to disk just as before, and you have some agent that's tailing the log, and every time it sees a new message, it ships it off to a stream. These are pretty common cases. You'll see message queues a lot here. In addition, on-demand loading. So in this case, it's a little different than batch, where in the batch world, you really always want these long data windows. You want to know what happened. In the stream world, you tend to, not always, but you tend to see more transient workflows where you don't necessarily need all the data for all the time. You might want to know what happened in the last 5 minutes or the last couple seconds, right? You're really completely flipping on the head the consumer use case. In addition, you also tend to see more schemas bundled with the message. So for those familiar with something like Avro, right, you can actually, in each message as it flows through the system, wrap the message in various schema metadata, encode it in a way that you can reference that later. And each message can have a slightly different version of a schema. That's kind of cool. Again, you can have batch with schemas bundled with the message. These are all things that you can see. It's architecture. There's lots of ways of doing things. But these are things that we've tended to see. Why might you use it? Again, if you have transient or resource-constrained producers, right? In the case of the Internet of Things, you tend to see stream processing called out a lot, right? There's all sorts of reasons why. One of them This particular bullet highlights an Internet of Things device, as shown this morning's demo, can be fragile, can be fickle, can crash and burn. And so this idea of getting data off of them as quickly as possible is critical. But you need to do that. The telemetry that these things are generating needs to get to your systems quickly, lest they get stuck on the device forever. Messages are also individually addressable in a stream, right? You can look at each message and take unique action on each message as it flows through your stream, not in a batch case when it hits the end of the flow, right? Once it gets to the warehouse in the batch mode, you can query it, you can do stuff with it, you can ETL it. In the stream world, you can really take action on those messages as far upstream as you need to, as you want. It's really powerful. Short data windows I mentioned, right there, you can actually take advantage of the fact that messages are coming so quickly through your system that you can look at the last 5 minutes. You don't have to wait for the hourly batch to make it through. What you also get by putting this sort of stream processing layer in the middle is multiple consumers. And so I'll show you what that looks like as we talk about how MediaMath really got past its batch problem. So again, the guiding principles from before, just as a reminder, because I'm going to jump right in. Stream processing feeds batch processing. Messages should move out of producers quickly, and schema changes flow downstream with the data. Just keep these in mind as we go into the Firehose. Where we were before, very batch, very difficult to scale. Where we wanted to go, loose coupling, highly available producers, multiple consumers. So taking all of this together, right, I want to put it all together with, these were the goals, this is where we wanted to go as a business, right, trying to figure out all the different ways we could solve this problem. All the things that we were learning about messages and queuing and streaming versus batch. And we put it all together and came up with Firehose, which is the diagram I showed you from before. To dive in a little bit more, though, same data on the left. So I want to be clear, this project was not about adding new data streams. It wasn't about changing our business logic, changing the types of information we were collecting, right? That wasn't changing. We're always at MediaMath adding new data streams, adding new data sources. It's all very exciting, but for the purposes of this project, it was don't disrupt that, right? Replace completely, drop in a new messaging architecture. So we did that, and now we're firing single events from these sources into Firehose. Firehose, effectively, if you drill in, we're using Amazon's Kinesis as a message queue. We really like it, but there's a ton of other options depending on what you're trying to do. We played around with Kafka for a little while. I'm sure some of you have experienced with some of those and other systems. There's also a layer within Firehose that does ETL, or stream ETL. So what that means is, as messages flow through Firehose, we have this collection of microservices, and each one of them is designed to enrich or filter the data in a very specific way. So it's almost like an assembly line where as something flows through, maybe it gets spray painted red, maybe this part gets swapped out, maybe this thing gets bent. But by the time it makes it out to the other side, we put it back into another message queue where the data is now enriched and available for consumption, available for people to consume that data. So that's really the core of Firehose. Now, on the consumer side, some of the things that we were doing with this data now included real-time analytics, right? We're able to actually take action on this data now as it's happening, targeting these users as they do things online. We were powering our decisioning and optimization systems, right? We were learning what our users were doing as they were doing it, as opposed to a nightly scoring job where we were collecting all this data and then training our models after the fact, well after the fact, and then coming back. We were doing all of this now much more real time. The last one, which seems kind of strange but ties back to what I mentioned at the beginning, is we were archiving the data. And so if you all leave with nothing but this, it's stream processing is really cool and you can take action on data as it flows through and it's awesome. But as long as you have a finance team and you're charging your customers, you're going to need nightly reports, you're going to need billing, you're going to need batch analytics. So make sure that you're archiving this data, right? In addition, stream processing systems tend to have short data windows. In Firehose, we actually said after 24 hours, messages are gone. They're deleted from the system. They're no longer available for people who want to subscribe and grab data out of Firehose. It's a pull model. The data's gone. It TTLs, it expires. However, since we're archiving that data, if you're a new consumer or a report that wants long time windows and stuff that's happening right now, you can actually go to the archive, go to the warehouse that didn't go away, it's still there, and get the historical data that you need to do your job. If it's a new cache layer that's spinning up and it needs to materialize, there's lots of use cases for going back through time, grabbing all this static data and using it, the event sourcing world, et cetera. We wanted Firehose to really be constrained to 24 hours. For some of your use cases, you might even want less than that. You might want 1 hour. I've seen great examples of, like I think other companies have done 30 days instead of 1 day. And that's it, and they don't have anything beyond that archived anywhere. That's okay. These really depends on your use case, your constraints, your trade-offs. For MediaMath, we wanted 1 day. We thought that was good enough. So far, so good. We found that that's a really great boundary. It turns out when Amazon launched Kinesis, they also said 24 hours is good enough. So our desire kind of aligned with what they were doing. And even if we wanted to do something other than that, we couldn't, because that's what Kinesis enforces right now. If you want to do something other than 24 hours, you might want to look at other options. That's something to note about Kinesis. Works well for us, might not work for all of the use cases out there. In addition to what I just mentioned, this wasn't trivial, right? There's challenges like how long do you retain data? Some of the challenges that we ran into, I wanted to highlight, because again, this is an architecture talk. It wouldn't be really a talk unless I talked about challenges. The first really hard thing for us, going from this batch mode to a stream mode, was writing to a stream API. Seems really intuitive. Well, okay, you have a web server that's listening for messages, and as it gets them, it should just relay them on to the stream. Well, that's easier said than done, especially when you're used to logging to local disk and having a directory that's always available to you, and a highly available producer, or a big beefy producer. It's a mental shift to really get there. That was hard, and something that we really need to educate the company on. How do you actually do this? How do you embed these stream APIs into your software, into your services? Not trivial. One way that we actually solved this for some of the applications that were slower to adopt was we dropped an agent, a daemon, on those machines that just listens for the log files, the legacy log files, and just streams the logs, it basically tails them as they're written. So there's lots of ways to do this, but this was something that was a hurdle for us. The second challenge was the other side of the problem, consumers. And I think this is a much harder problem. Consumers thinking stream, that phrase, is just, we're not there yet as an industry, right? Like, if you have a consumer of data, somebody who's running a report, report writers kind of think of data as static and historical, and why wouldn't I have access to a year's worth of data right now at my fingertips using SQL? So changing that mentality to, yeah, that's okay, we're always going to need that, but instead of having a report where you showed loads, in this case, users went to my website X times yesterday, and showing that in your product, wouldn't it be cool if you could show what they were doing in the last 5 minutes as like a spark line or something? That would be really cool. Customers would love that. So changing that conversation, right? Having that discussion, I think is just as important as the architectural backend, so deciding which messaging systems to use, how data flows through the system. It is just as important if you're going into your companies and you're trying to move them out of this batch mode to do stream processing. Think about the evangelism, the education, as a tremendous curve to overcome. Most of the people in your companies that you have to convince are not here today. You can send them the link to this video if you'd like, but there's a lot of education that has to happen. That was a tremendous hurdle for us. We got through it, we're better for it. I think a lot of the architecture patterns you're hearing about today, microservices, et cetera, same problem, right? It's a lot of education. And a constantly changing ecosystem and tools that are nascent like Storm, right? Cool, still getting there. The other issue for us was loss prevention. When I say loss prevention, by the way, as an aside, I think of like a guy stealing a VCR. It's not what I mean. This is like data being dropped out of your pipeline, right? You lost it, you don't know what happened. In the batch world, this means a file went missing. Right? For those of you that are used to batch-oriented pipelines, as I am, if a file goes missing, that is very bad. That is one of those situations where you get called at 3 o'clock in the morning, your time, not somebody else's time, and paged and told to go deal with it, go find the file, wherever it may be. The reality might be that that file is gone. The producer that was logging that file never made it through the system. The data is lost. So we wanted to get better at that. We wanted to make the system more reliable, as I've mentioned several times. And so one way we did that was moving messages off the producer as soon as they happened, right? So the producer tier was no longer the source of loss, which really constrained the problem better for us, especially getting that call at 3 in the morning saying data is missing. The search criteria, the boundaries for debugging get significantly tighter and easier. In addition, we added an audit layer. This is a new thing for us. There's not a lot of great technology in the space, so we hand-rolled something. All it does is it keeps track of a window ID. If you're used to files, it's like a batch ID. where every message as it hits the system is tagged with a window ID. Right? And this window ID gets tagged to, say, 10,000 messages. And on the other end, and as it flows through every step of the process, we record that this message ID made it with this window ID to this stage. And so what we can do is basically tracing, right? What we can do is say, you know what, by the end, 10,000 messages made it through with this window ID. That's what we expected. That window is all set. We know it got there. In the case where maybe 9,999 messages made it, an alert can go off, and you can say, you know what, we lost a message. The nice part about stream processing is you can go back to the stream, provided it's within the 24-hour window, in our case, and you can go get that message and replay it. And that works really well for us. So a lot more around reliability and auditing that we had before. Finally, balancing batch and stream. Right, so in the sense of convincing consumers to go stream, to use stream, we still had these batch use cases, and we didn't want to lose them. They're very valuable to us. But finding that balance, right? How far down the pipeline do you slow down the data? Right? I can't say this enough. The momentum of the data is fundamental to me, to my team. But at some point, you do have to slow it down for these batch consumers. So where do you do that? How do you do that? That was a challenge for us to balance. For each of you trying this, you might have a different use case. You might want to batch as far upstream as you need to. You might want to never batch because you're just doing transient processing, period. That's OK. There's lots of use cases. We actually, just as an aside, when we batch, we write that to S3. We're AWS, so Kinesis for stream process, or the actual messaging queue, and then S3 for our archive storage, just as a note if you're looking at that particular stack. All that said, I think we've unlocked some really cool opportunities, and I would be remiss if I didn't go into them. The first is innovation speed. So if you can take action on messages the second they hit your system, right? If you can decouple how data flows through your system, right? Now that you're using streams, where streams, you can put schema at the top, right? So the use case, and I'll walk through this one briefly, because I think it's really something a lot of people can relate to. The case of, I want to add a new field to my data, right? I want to add a new field to my data, and I'm a producer, and I want to collect some new information at the edge, really cool stuff. But first, I need to check with the warehouse. I need to check with the consumer that they can go add a nullable column to their table. Because when they're bulk loading these CSV files inline directly into the database, and they see a column they didn't expect, that's going to be bad. And some database technologies are better than others, but in a lot of cases, that's not a great situation to be in. So in the old model of the pure batch, you really had to spend potentially months coordinating across different teams, from the warehouse to the web tier and everything in between, to figure out in what order you were going to sequence this so that you could add this one new column, which for us really meant innovation and experimentation became a little too costly to bother. So files would maintain the same schema for years. Not a great model. With stream processing, what we were able to do, and what we have done since then, is anytime we want to add a new column to the data feed, we just do it. And the consumer of the data, right, that's pulling data directly from the stream, just pulls the columns they want out of the messages, because they're pulling. And that works really well. So we've been able to really speed up how quickly we can experiment. Real-time analytics came out of nowhere as well for us, where now that we could take action on data quickly, we could be responsive. We could, change our system directly in response to actions that were happening from our users right now. We could stop serving an ad in the case of a purchase, as I mentioned before. So all those together, really, it's cool as an engineer, as an architect, to go in, rebuild something from scratch, try new technologies, but ultimately, we're a business, and customer value is top for us. It's important that our customers ultimately are the beneficiaries of these decisions, right? Microservices are cool. Stream processing is really cool. But if your customers don't see it, and you just improve the reliability of your system, that's OK. If they can directly benefit from your decisions, that's a huge win. That's a no-brainer. If you're going back to your companies to try to sell them on stream processing, sell them on the fact that customer value is directly proportional to the speed at which they can take action on the data that's hitting your system. So all that said, thank you. That's all I have for today. And it's late. It's party right now. You guys have been here all day. So thank you very much. I'll be hanging around for questions for a while. But that said, appreciate your time today. A question over there. Yes. Sorry, it's very bright up here. I apologize.
How would you compare? I'm aware of Apache Storm now. contrast or similarities between what you set up and what Apache Storm has now?
Sure. So the question is comparing and contrasting Apache Storm as a project with what we've built to do stream processing. The reality is when we first set out to do this, Storm was very nascent, and it was a little too, at risk of offending somebody who works on this project, it was a little too alpha for us. And I think it's come a tremendous way since then. I definitely advise, if you're getting into stream processing, look at it. We're actually experimenting with it now to see if it works well for us. What's nice about Storm that I think a lot of other stream processing systems miss is this idea of a topology, where you can actually track your directed acyclic graph of data as it flows through and all the different ways it's routed. The way we do it is really, it's just linear, where messages, as I mentioned, it's like a conveyor belt, where we're just changing the data as it flows through the system. It's very uniform, very sort of single line, not necessarily a DAG. I think with Storm, you start to get into that, which is cool, was kind of overkill for us initially. There's also Samza, which I know LinkedIn was working on, and there's a couple other cool things to take a look at. Yes?
How do you handle event correlation or aggregation? You've got a byproduct use case where you need to look at a series of events and correlate them.
Sure.
Need for systems somewhere to do that.
Yeah, so the question is, how do we deal with aggregation? And so you're asking specifically, how do we, MediaMath, deal with that? Or how do we, in general, with stream processing? So you're starting to get into event sourcing. And there's several other great talks that have been going on, and I think there's one going on at the same time as this one, so watch the video if you have access to that. But the idea here is if you want to have access to not just the event stream, but you want summaries of what's going on in your stream, you want to keep track of that, the way you would do that is to have a consumer that is keeping track of those aggregates. So if you have a stream of data, it's a message queue, and you're pulling off that stream in real time, the consumer is ultimately the one responsible for keeping track of those aggregates in this diagram. And again, one person's input is another person's output. In the event sourcing talks and sort of architecture that exists, where we stop in this diagram, event sourcing begins. I think of an event sourcing layer as a consumer, a very important consumer, but a consumer of a stream processing system. If you hear any of the other talks, the idea that the data is coming in as a stream is a given, it's an assumption. So keep that in mind. You can also do this from batches as well. If the data is sort of time ordered, you could do this. But yeah, that's the consumer's problem in this model. And the way we've done that at MediaMath, just as a note, is we right now just sort of nightly comb the data like once a day and just kind of keep track of what's going through, because we don't use the aggregates really on our end. If you do and you need to keep like a running total of what's going on right now, you start to run into interesting challenges like, when do you reset your counters, and what are you aggregating exactly? Are you aggregating sale prices of what products, and are you just looking at it today, and are you storing that in like a DynamoDB table? These are all very valid things to do, but they are just tangentially outside the scope of that diagram. Just Firehose is not meant to solve that problem. Yes? Sure, so the question is, why do we go with Kinesis over Kafka? Couple of reasons. The first is we didn't really want to manage it. We didn't have a huge operations team at the time, and Kinesis is a much more managed version of the solution. So we were willing to go sort of all in on Amazon's, pay for it, we'll take care of it for you, we'll keep it running. That was purely the main reason for it. The other slightly lesser reason was, at the time, Kafka's developer ecosystem didn't seem like it was really taking off. We weren't sure if it was going to go like the way of Flume, where it wasn't really going to ever continue development. We just didn't know. Amazon, we've been trusting pretty well with technologies like this. We figured it wouldn't go anywhere. And it turns out Kinesis is one of their hottest new products as far as I can tell. So I think it was a good investment on our part. Might be different depending on your use case, though. So did you have a follow-up? I just want to make sure I finished the... So the question is, I mentioned that we're looking at multiple consumers as an objective of this new design. What is maybe an example of a consumer that isn't the warehouse? Is that? So an example of a consumer that isn't the warehouse might be a real-time targeting system. So in this case, it's a system whose job, a service really, whose job it is to answer questions of the form, what's going on in our system right now? as an example. It's a very generic description of the system, but that's the idea. So it's a totally unrelated to a warehouse type of system. Those familiar with event sourcing, if you're trying to like materialize a cache layer from a stream, these are all non-warehousey systems. Systems, I want to be clear, I'm not talking about Hadoop, by the way. This is very important to the Hadoop folks in the room. I'm also not at Strata, so I guess I can say this. Hadoop is great for stream processing. It is not a batch system. The Hadoop ecosystem is ridiculous. And like I know Storm can run inside Yarn. Like these are all things that happen now. So I'm not talking about necessarily Hadoop. Just wanted as an aside. I think that's interesting. But I hope that answers your question. So I saw one up here and then one back there. Yes?
So the real-time analytics, the queries need to run against live data. What does it sit on top of the dashboards, the analytics that you're running? Is there any memory database or something that you run on top of?
Sure, the question is what is the infrastructure behind the real-time analytics system? It really depends on the use case. In our case, we have two types, and I think you basically just hit on both of them, where the first is a very transient analytics system. So imagine a system that's almost a distributed RPC call, so where you ask the system a question. In the microservices world, it's a service whose sole job it is to answer questions of the form, how many clicks just happened in the last 5 minutes? Globally, how many clicks just happened? No state required, period. It's a totally stateless service where it's pulling off of the stream, starting at maybe the head of the stream now, and just listening to it for a little while, and then returning the result of what it just heard, right? A forecaster or something like that. That's one example, totally stateless. Another example might be, to the case of aggregates, keeping track of rollups. I want to know what's been happening. In that case, absolutely, you'd want something like, in memory or a more persistent database. We've used Redis to do this. We've used DynamoDB. There's a lot of technologies to do this, but yeah, that's keeping track of aggregates might be the other example. Yes?
The question is very similar to that, in that the real-time analytics, that would store the data that's in the stream as opposed to data that would be in the warehouse. So if you wanted to do analytics over more than 24 hours, right?
Mm-hmm.
Does that mean you have to wait until it's into the warehouse?
So the question is, what happens when I want to do analytics that is based on both real-time streaming sources and batch sources? Is that a fair characterization? You're getting into the fabulous world of Lambda architecture, and I could probably go on about this for a little while, but there's a lot of ways to solve this particular problem. We don't do that today. The way that our analytics is designed is really it's one or the other. We believe that if you're sort of logging all this, we actually have a Cassandra database that we're logging all of this information to, so we're actually keeping, it's almost a secondary warehouse where it's just a NoSQL key value store where we can just query all of this data going way far back and sort of dynamically interpret it. That's how we do it, where if we need to query a lot of data, we expect that the query is just going to take longer, but we're actually updating this warehouse, this new warehouse in real time. If we want to do more transient and really just last couple seconds, querying a year's worth of data is like totally overkill. It's not worth it. The amount of, just like if you're using Amazon, like the EC2 resources required to process all of that data is a huge waste of time. So you want like a spot instance that can just spin up, grab data off the stream, and return a result. So I think it's a spectrum. There's so many different use cases, but yeah, I've seen both of those in use at MediaMath. Any other questions? It's very bright in here, so if your hand is raised, say so. Otherwise, I think we're good, and enjoy the party. Thank you so much.